here's an electron micrograph of an endothelial cell. I don't think it's the same one Nigel showed, but it doesn't really matter. We've got the nucleus here. We've got a junction here, and it's a probably tight junction, and then a portion of another cell. Right? So I have seen capillaries formed by a tight junction in itself. Right? This one is nice because you have this cell right here surrounding it, which is called a parasite. It's kind of a hybrid between a muscle cell and a connective tissue cell. All right, so at any rate, this luminal diameter is on the order of 7 to 10 microns. Just what it would take to have a red blood cell work its way through. Okay, on to lymphoid tissue. We are clearly looking at here. All right, well, we're looking at several things. Peyer's patch. Peyer's patch would tell us we're looking at what region of the small intestine. Right. And we know it's small intestine because we can see all these finger-like projections, which are... Okay. Before we talk about Peyer's patch, let's do the organization of the gut wall. All right? So we'll start from the lumen. The mucosa consists of what?
This is columnar simple columnar.
Okay, an epithelium which is simple, columnar. We've got goblet cells. The connective tissue core of a villus is called what?
Lamina propria.
And it's an example of what kind of connective tissue?
Loose.
Loose. Good. You can just hallucinate it at this magnification, but humor me. This region right in here, interrupted here, a couple of smooth muscle cells thick is called the...
Muscular mucosa.
Exactly. So the mucosa consists of the epithelium, the lamina propria, and the muscularis mucosa. The Peyer's patch, for the most part, and then this region right in here, is what? Submucosa. Then we've got this region out here, which is called the... which consists of an inner circular, and this is by definition, right? Because it's wrapping around the lumen, and an outer longitudinal. We know we can find myenteric plexus of Auerbach in here. If we're lucky and have a good eye, we can find Meissner's, submucosal plexus of Meissner. See this little bit of fat up here? If we were to look carefully here, we might see the simple squamous epithelia cell, or nuclei of mesothelium. So this is kind of suspending here. If we were really lucky, we could pick up the serosa out here. Out here, there's not going to be fat. There might be a little bit of loose connective tissue, or it might just be the mesothelium right down on the longitudinally oriented muscle. Okay? So, clearly with Peyer's patch, you've got, what are there, 12, 14 nodules, right? Most of them have germinal centers. In the nodule, the majority lymphocyte would be B, but we're going to always have a few T helpers, right, to tickle them, if you will. But those T cells that aren't tickling hang out in this interfollicular area. Okay? Here's a higher power shot, and we can see nicely lamina propria, this cross-section through a villus, the goblet cells. Here, we get just the sense of the muscularis mucosa, which is interrupted because the infiltrate has moved from the submucosa up into the lamina propria of the mucosa. All right? If you were to look carefully in a lymphoid follicle that has a germinal center, you could find mitotic profiles. Because, as I said in lecture, these puppies are proliferating. All right? This follicle has been exposed to an antigen. Okay, nice low power context. And it illustrates something that I want to see you all doing on the exam. All right? If the question or the station has a microscope with a glass slide, I expect you to pick up and look at the glass slide. I expect you're not going to drop it. Believe me, the sound of breaking glass is like really loud in an exam. All right? But I do want you to look at the slide. The next thing I want you to do is put it on the stage and with low power circumnavigate the whole periphery. right? When you do that, you get all sorts of impressions, you know. With this palate and tonsil here, one of the things you got to figure out is what's a cut surface and what's an epithelial surface. Well, this is clearly a cut surface. Look, we slice these secondary follicles in half. Here we start to pick up connective tissue, might have a bit of mucus gland. Not surprising. You know, your pharynx produces a lot of mucus, whatnot. But we here see this connective tissue. And then we come up here and it looks clearly an epithelial surface, right? You do that circumnavigation, you'd be surprised with how much stuff you've got in your head. Then you go to the higher powers if you need to, all right? Please keep that in mind as you do the exam. All right, so clearly, connective tissue, we've got an epithelial surface. If we went to higher power, we would know that this is what type of epithelium for a palate and tonsil? All right, I heard it all. That's what we want. Now, if you look at this, you can see these spaces right here. Those are going to be crypts. Now, some of you are going to be lucky enough to see the point where the epithelium invaginates into it. Those of you that aren't, you realize that above or below the plane of section, that space would be a continuity with this surface right here. Okay? Here's that higher power shot. Now you're going to find cellular debris, food, whatnot, just a bunch of crap in the crypt. So we've got a germinal center, germinal center, germinal center. Higher, you can just get a sense that that's probably epithelial surface here. It can be so infiltrated with lymphocytes that it's really hard to tell what's happening. So that's why the circumnavigation trick helps you, because you're going to find some region that tells you it's stratified squamous non-characterized. Okay? Okay, nice low power shot of a lymph node. All right? We've got an encapsulated structure. You can see a fine capsule here. And even at this magnification, you can pick up that subcapsular sinus. Okay? You've got evidence of follicles. Here's a secondary, which is primary. Secondary, you've got a cortex and medulla. All right? You go to higher power. Again, I showed you these in lecture. They're oriented differently. So here's the connective tissue capsule, right? This is that subcapsular sinus. Sometimes it can be really filled with cells, so it doesn't show as well. And then here's a trabeculum. You can see the continuity with the capsule. So trabecular sinus. These connective tissue trabecula move all the way to the medulla, and then in between the medulla, what do we have to help provide the organization? Support, the structural support. Reticulum. Okay?